So, this is the first example we took, right, and one small correction you make, actually this one actually it will be divided by a square, right. When I was going through it, by mistake I multiplied a square, it should be divided by a square, then this is correct, right, rest is okay, right. Next is that example, then come to the second example. This is actually now little bit slowly we will go to the different type of problem. Now, figure 10 I will show you, it shows single line diagram of a single phase circuit, right, using the base values of 3 kVA and 230 volt, right. So, you have to draw the per unit circuit diagram and determine the per unit impedances and the per unit source voltage. Also calculate the load current both in per unit and in amperes, right. I mean, you have to calculate per unit values as well as in terms of your current values, now ampere values. Now, this is the diagram, this is sending end voltage 220 angle 0, this is actually kV, right, 220 just kV or volt, just let me see this, right, 230 volt, actually small system 230 volt. So, this is your what you call base values 3 kVA 230 volt, right. So, this is actually 220 angle 0 volt, this is the section 1, this is figure 10, this is a transformer T1, this is line resistance is line reactance is given 3 ohm, right, and this is transformer T2. So, and this is the load impedance is given 0.8 plus j 0.3 ohm. So, this whole thing has been divided into 3 sections, this is section 1, this is section 2 and this is section 3. Now, for transformer T1 it is given 3 kVA 230 upon 433 volt, this is the rating of the transformer, and equivalent reactance is given 0.1 per unit, right. Similarly, for transformer T2 this one is 2 kVA, this transformer is 440 upon 120 volt, right, and XEQ again 0.1 per unit. These are the data given, right. Now, first what you have to do is you have to choose base values, right, and in this problem that is given that you have to take base value 3 kVA and 230 volt, and based on that you have to determine everything, right. So, when base MVA it is base kVA is given 3. So, you convert it to MVA. So, it is 3 by 1000. So, 0.003 that is your base MVA, right, and this base value will remain same for the internet, that is this base value will not be changed, it will remain same as it is, right. And base voltage it is given that is your 230 volt, but if you look into that means this transformer that 3 kVA and 230 volt basically it is given as a base for you, right. Therefore, this section 1, right, you write that voltage base 1, that is for the section 1 is 230 volt, that is 0.23 kilovolt, right, as specified in section 1, because this transformer T1 actually 3 kVA 230 volt. So, this side is section 1, right, this side, right. Now, based on that you have to transform the base voltage to the line as well as to the other side. Therefore, when moving across a transformer, the voltage base is changed in proportional to the transformer voltage rating. Therefore, that for section 2 base voltage will be 433 by 230 into 230 is 430 volt. It is, if you see that this side is to a base, it has been asked that your base voltage is 230 volt, that means this side. So, when transformer is 433 volt rating, so automatically this side will be base voltage will be 433 volt. That is why, but you have to transform. So, it is 430 by 230 into 230, that is 433 volt. So, this is actually 0.433 kilovolt, right. Similarly, for the base voltage for section 3, that means this side basically transformer actually 440 upon 120, but this line's base voltage is 433. So, accordingly you have to see what is the base voltage for the section C, that is your this side, right, that is your this portion, right. That means your VB3 will be 120 upon 440 into 433, because you are going to the lower voltage side, although transformer is 440 by 120, but you are transforming whole network into a based on a common base, right. Therefore, this section 3 base voltage will be 118.09 volt, that is 0.11809 kV. So, hope you have understood this, right, that how to transform. Similarly, now for the section 1, ZB1 is the base impedance is equal to VB1 square upon MVA base, that is your 0.23 square upon 0.003, that is 17.63 ohm. This is the base impedance for the section 1 of that diagram, right. Similarly, for ZB2 is equal to VB2 square upon MVA base, right. So, that is equal to your 0.433 square divided by 0.003 is equal to 62.5 ohm, right. So, similarly, ZB3 is equal to VB3 square upon MVA base is equal to 0.11809 square upon 0.003. So, 4.64 ohm. So, all the 3 sections base impedance are computed, right. Now, base current in section 3 is that for the section 3 base MVA base remains same throughout. Therefore, base current in section 3 IB3 is equal to MVA base upon VB3, that is 0.003 upon 0.11809 kilo ampere, and that is equal to 25.4 ampere, right. Now, it is given xq is equal to 0.10 per unit. This is actually old value. So, we are writing because we have to convert it to the other base. So, x1 old is equal to x1 q 0.10, but x1 new also 0.10 per unit is equal to x1 old, because this is for transformer. Your rating 3 kVA, that is 0.003 MVA, and 230 volt is the base. So, for transformer T1 this will not change, it will remain as it is, because transformer rating itself has been taken as a base, that voltage as well as your volt ampere, right. Therefore, for transformer T1 no change in per unit values leakage reactance, right. For transformer T2, ZBT2 is equal to again that 0.44 square divided by your 2 by 1000. The reason is like this, the transformer T2 actually it is 2 kVA, right, and 440 volt by 120. Therefore, the base impedance for transformer T2, right, first you find out. Therefore, transformer this your primary side it is 440 volt. So, 0.44 kV square, because 0.44 kV divided by it is 2 kVA, because rating is for transformer T2 is 2 kVA, 2 by 1000, that is 2 by 1000 MVA. So, MVA that is your kV square upon MVA, that you will get 96.8 ohm. This is transformer own base, right, that based on its rating. Now, transformer 2's reactance is given 0.1 per unit. Now, find out what is its ohmic value. So, x2 ohm is equal to x2 per unit into ZB2, that is 0.1 into 96.8, that is 9.68 ohm, right. That means, x2 new now is equal to, because new base impedance, that is for your what you call that ZB2 we have got this value, that 60 for the section 2 ZB2 we have got 62.5 ohm, right. Therefore, a new value of that reactance of the transformer 2 x2 new 9.68 upon your 62.5, I have written here ZB2 is equal to 62.5 ohm, right. That means, x2 new is equal to 0.1548 per unit. Similarly, for the line x line per unit is equal to x line ohm upon ZB2, that is 3 upon 62, because line reactance is 3 ohm divided by base impedance of the section 2, that is 3 upon 62.5, that is 0.048 per unit, right. Next, load is given, load per unit ZL per unit is equal to ZL ohmic value, this is given 0.8 plus j.3, this impedance is given, divided by the base impedance of your line section 3, right. That means, section 3 base impedance we obtain ZP3 is equal to 4.64 ohm, this one, right. That means, your per units your ZL is equal to your ZL ohm upon ZB3 0.8 plus j 0.3 upon this is 4.64, that is 0.1724 plus j 0.0646 per unit, right. So, per unit circuit is shown in figure 11. So, you have in the circuit you have a source voltage Vs, that Vs actually it is given your 220 angle 0, but base voltage is 230 in the this base voltage is 230 is given. So, 220 upon 230 that will become actually 0.956 angle 0, this is 220 upon 230, right. For transformer T1 that is J 0.10 as it is, for the line it is J 0.048 per unit, and for transformer T2 J 0.1548, right, and for the load it is 0.1724 plus J 0.0646 per unit, right. So, here it is given 0.1724, this is resistive part because load is inductive, and it is J 0.0646, this is the load, right, and this is the per unit diagram. So, Vs also is 220 angle 0 upon 230 is the base. So, 0.956 angle 0, that is I have told you, right. Therefore, total per unit impedance ZTPU, the Z total, you sum it up all, it will right, it will become 0.4058 angle 64.86 degree, like this is the resistive part, right, this is resistive part, right. And so, therefore, IL per unit is equal to, that is IPU, because same current is going to the load, this is load. So, IL per unit is equal to series circuit, IPU is equal to Vs upon ZT, right. So, is equal to 0.956 angle 0 degree divided by this ZT, the total, is equal to, you will get 2.355 angle minus 64.86 degree per unit. This is your what you call, this is the per unit value of the current, right. Then that you have to find out ampere, no, we have you have to find out ILPU into IB3. In the we have seen that base current for that side is 25.4 ampere before. So, this per unit values multiplied is 25.4. So, this will be 59.83 angle minus 64.86 degree ampere. So, this is the load current, and current is lagging because load is inductive, right. So, this numerical you have understood, right. Now, we will go to little bit further tougher problem, right, slowly and slowly, such that all type of things will be clear, that what then you will know what is the advantage of this per unit conversation, conversion thing, right. So, figure 12 I will show you, it is a big diagram, shows single line diagram of a power system, the ratings of the generator and transformer given below, right. So, this is actually your, before giving the data, this is actually your figure 12, there are 3 generators, generator 1, generator 2 and generator 3, right. Now, this generator 1, this star connected, it is grounded, generator 3 is not grounded, generator 2 is grounded, right. So, generator 1, it has 25 MVA rating and 6.6 kV terminal voltage. This transformer is a delta star is grounded, it is a delta star transformer 6.6 and 115 kV, right. Similarly, and this line, it is line 1, it is only reactance we are considering. So, J 120 ohm, and this is generator 2, it is star connected but grounded, it is 15 MVA 6.6 kV. This transformer actually delta star, delta side is 6.6 and star side is 115 kV, right. And this is your line 2, this is J 90 ohm, this is the your what you call, this is the line reactance, right. And this is transformer 3, these two transformers are 3 phase transformer, this one and this one 3 phase transformer, but this transformer actually, this 3 phase transformer actually 3 single phase transformer are connected. So, that is why that each single phase rating was 69 upon 6.9 kV, but as it has been made 3 phase, it is star secondary side is grounded, that is why root 3 into 69 slash 6.9 into root 3 kV, because single phase it was given 69 by 6.9 high voltage to low voltage, but when you are making it your star connection using 3 single phase transformer, and all this thing we have to represent it, line to line voltage, that is why multiplied by root 3, and here the secondary side also multiplied by root 3, and this generator is star, right, connected. G3 is 30 MVA and 13.2 kV. This is the single line diagram. You have to make that means this one you have to make single line diagram of this one, right, generator given below. So, you have to what you have to do is that you have to find out its per unit your reactance diagram. So, G1 is 25 MVA I told 6.6 kV, generator rating is generator reactance is given 0.2. Look, everywhere J will be there, but not putting J, only in the final circuit we will put the J, that complex operator, right. So, G2 is equal to G2 rating is 50, generator 2 rating is 15 MVA 6.6 kV and reactance is 0.15 per unit. Similarly, generator 3 it is 30 MVA, right, and 13.2 kV and it is generator reactance is 0.15 per unit. Transformer T1 is 30 MVA, it is 6.6 delta side kV and 115 star side kV, right, and transformer reactance is 0.10 per unit, right. Similarly, for transformer T2 it is 15 MVA, it is 15 MVA 6.6 kV delta side and 115 kV star side. I am writing kV here, but understandable, right, and reactance is for transformer T2 is 0.10 per unit, and transformer T3 actually single phase unit, each rated 10 MVA, right, and 6.9 upon 69 kV and XT3 is given 0.10 per unit, right. So, as it is a single phase transformer, that is why line to line three single phase transformer connected to 3 phase transformer, 3 single phase transformer and 3 phase transformer, that is why line to line voltage you have to multiply this one by root 3 and this one by root 3 kV, right. So, you have to draw the per unit circuit diagram is the base values of 30 MVA and 6.6 kV in the circuit diagram of circuit of generator 1, right. If base value is given, that you have to take 30 MVA base, MVA base should be 30 and base voltage should be 6.6 kV. Based on that, you have to make this diagram single per unit your reactance diagram, right. So, how we will do this, right. So, the chosen base values are given 30 MVA and 6.6 kV in the generator 1 circuit. That means, this side you have to take the 6.6 kV, but this side base is 30 MVA, although generator rating is 25 MVA, 15 MVA and this side is 13 MVA, right. Therefore, the transmission line base voltage of line 1 is 115 kV, because the generator side voltage, generator terminal voltage is 6.6 kV, this transformer also 6.6 kV. So, automatically this line, this side base voltage will be 115 kV, because this is your secondary side transformer voltage, right. So, that is why, and for generator 2 base voltage is also 6.6 kV. I mean, for this generator also the terminal voltage 6.6 kV. So, base voltage also 6.6 kV, right. That means, so here actually directly connected, no line is here. So, no impedance is reactance is shown or impedance is shown, means it is directly connected, right. So, this side base voltage is 115 kV and automatically base voltage 6.6 kV is taken. So, generator terminal voltage is also 6.6 kV. So, other side base voltage will be 115 kV. So, absolutely no problem. Now, next is that as the transformer T3 is rated 6.9 kV and 69 kV per phase, because 3 single phase transformer we have used, therefore, line voltage ratio will be 6.9 root 3 slash 69 root 3, right. That is, if you multiply by root 3, it will be basically 12 on the low voltage side 12 kV and high voltage side will be 120 kV line to line, right. Therefore, baseline voltage for generator 3 circuit is that it is for this generator, because this transformer actually 12 your 12 kV by 120 kV. So, but line base voltage this side also it is line base voltage is 115 volt, right, but this side should be then 12 by 120 into 115, that is this side will be 11.5 kV, this generator this side, right. So, that means that baseline voltage for generator 3 circuit will be the 12, because transformer is now 12 by 2, it is 12 by 120, right, but your base voltage this voltage is 115 kV, that line side. Therefore, this side voltage will be 12 by 120 into 115. So, 11.5 kV, right. So, that is your this side base voltage. So, this way you have to transform and you have to make things correctly, right. I hope you have understood this, right. So, once this is done, then as MVA base is given, as MVA base is given 30 throughout this, generally base voltage generally base MVA generally do not change. So, MVA base 30, but first generator, right, but first generator that its rating is 25 MVA, but on the base voltage is 6.6 MVA. That means, in proportion to the ratio of this base MVA, this reactance will change. So, Xg1 is equal to 0.2 into because 0.2 was given. So, into 30 0.2 is on its own base, right, on its own rating. So, but 0.2 into 30 upon 25, that is 0.24 per unit, because you have to convert everything on a common common MVA base and common voltage base, right. Similarly, Xg2 will be 0.15 into 30 by 15, because generator is 15 MVA, but base MVA is 30. So, it will be 0.15 into 30 upon 15, that is 0.30 per unit. Now, in the case of generator 3, base MVA is 30 and this is also 30. So, the ratio 30 by 30 will be cancelled, but it will become 0.15 into 13.2 upon 11.5 whole square is equal to 0.2 per unit. The idea is if you have any confusion, it will be something like this, right. I have made some calculation for here for generator, this thing generator impedance actually given 0.15 per unit for generator 3, for this generator it is given, data it is given. So, its rating is 13.2 kV on its own rating or own base 13.2 kV and 30 MVA. So, 0.15 into 13.2 square upon MVA base. So, MVA base is this generator is 30 MVA and MVA base is also 30 MVA. So, ZB3 is equal to that your your base impedance on is, when you convert this base impedance, MVA base both the cases same 30, but it is base for the this side that is the generator 3 side, we obtain base voltage 11.5 kV, right. That means, this ZB3 11.5 whole square by MVA base, right. This is actually ohm, we convert it to its own rating and this is the base value we got 11.5, right. Therefore, Xg3 per unit will be Xg3 upon ZB3. This is Xg3 means these ohmic values, right. So, if you put it here, the MVA base will be cancelled. So, finally, it will become your Xg3 per unit 0.15 into 13.2 whole square upon 11.5 square, and that is per unit, right. That means, your Xg3 will become 0.20 per unit, right. So, this way you have to transform. For transformer 1, Xt1 0.10 per unit, right, because transformer your where is this rating, I will show you the data. For transformer, similarly for transformer also base MVA 30, transformer rating is also 30. So, base MVA will not affect, but voltage will level we have to see. So, for transformer Xt3 will be 0.120 upon 115 square, because this transformer T1 actually 115 your what you call this transformer T1 and lines other side is 115. So, transformer T1 will remain same, because base voltage 30 MVA 6.6 kV. So, primary side, so secondary side is 115. So, that is why there is no change for transformer T1, right, it will remain as it is. Now, for transformer T2, it is rating is just 1 minute, let me find out the data. T2 transformer T2, it is 15 MVA, but again 6.6 delta side 115. So, voltage will not affect because 6.6 kV is the your base voltage. So, other side will be 115 automatically, but rating MVA rating is different 15 MVA, but base MVA is 30, base MVA is 30, right. That means X2 will be 0.1 into 30 upon 15, same as the generator we are doing. So, it is 0.20 per unit. Similarly, XT3 for transformer T3, right, it is 3 single phase transformer has been made, but its rating is per unit it is 0.10. So, if it is 3, remember listen one thing, that for single phase or 3 phase does not matter, even it is given per unit means you have to take 0.10 as it is 3 phase. So, please do not multiply by 3 or root 3, it is per unit given, otherwise things will be wrong, whatever is there you will take, right. So, XT will be 0.10 and base MVA is 30 and transformer rating is also 30 MVA. So, only that 0.1 into 120 upon 115 square, it will be, if you, that is equation 16 again or same as before, that whatever I have made it similar way, you will get this 0.11 per unit, right. So, all these impedances you have got, right. So, here also for this calculation I have made it here also for you, you can go through this one also, right. And now, for line it is 115 kV is the line base voltage. So, ZB line is 115 square upon 30, that is 440 ohm. So, X line 120 by 40, 440 is equal to what you call 27 per unit, because line reactance was given 120 ohm. So, it is 0.27 pu. Similarly, for X line 2 is equal to 90 upon 440, that is 0.205 per unit, 205 per unit. Now, that look at this diagram. Now, you see this equivalent, that per unit diagram, right. So, this is generator 1 and this is your generator 1, right. So, it is 0.24, Xg1, Xt1 is 0.10. So, this is transformer T1, then line is coming, then this is X line, J 0.27 we have got, right. Now, this is generator 2 is connected in between these two. So, it is generator 2, it will be in parallel, right. This G2 and G3 will be in parallel, right, these two are in parallel. Therefore, this is your XT22, this is XT2 T2, that is your J 0.2 here, right, and Xg2 we computed, that is J 0.3, this is generator 2. For then this line is coming X line 2, then this is X line 2 J 0.205, then XT3 is coming, that means this one is coming now XT3. So, it is J 0.11, then this generator Xg3 is coming here J 0.20 and complete the circuit. So, this is the per unit circuit diagram, right. So, this is G1 and G2 G3 are in parallel, that is why it is in parallel, right. So, this is per unit diagram. I hope this one you have understood, right. This is a slightly difficult one, but just you have to see, difficult in this sense that you have to see that you have transformed every quantities in appropriate base per unit values by converting that to the appropriate base, right. Base is more important, right. So, next is another one, this is another type, right. So, in this case a 100 MVA 33 kV 3 phase generator has a reactance of 15%, that is 0.15 per unit. The generator is connected to the motors, right, through a transmission line and transformer as shown in figure 14. This is figure 14, I will come to that. Motors have rated inputs of 40 MVA, 30 MVA and 20 MVA at 30 kV with 20% reactance each. Draw the per unit circuit diagram. That means, you have a generator, it is 100 MVA 33 kV, right, and Xg is equal to 0.15 per unit is given. This is what transformer T1 is there, it is 110 MVA transformer, rating is not mentioned here, but here it is mentioned 110 MVA. It is delta transformer, delta side is 32 kV and star side is 110 kV, all are line to line, and XT1 reactance of this transformer is 0.08 per unit, and then line is got, then this is the transmission line, this is a 60 ohm, this is 60 ohm, and this is transformer T2. Here also 110 MVA, transformer T2 also 110 MVA, voltage also 110 by 32 k slash 32 kV, that is high voltage side is 100. I told you earlier the star side generally kept for high voltage side and delta side is for the low voltage side, right. So, 110 by 32 kV is star, this side is star, this side is delta, right, and XT2 also 0.08 per unit. Now, here 3 motors are connected in parallel, right, one rating is 40 MVA and XM1 is equal to 0.20 per, that is motor 1 reactance. Similarly, 30 MVA another one, motor 2 is 0.20 per unit, and 20 MVA another one, and motor reactance is 0.2. J not shown not shown anywhere, but in the final per unit diagram we will put the J, right. So, assuming you have to, here nothing has been mentioned. So, you have to assume that MVA base is, you assume it is 100, right, and kV base you assume 33 in the generator circuit, right. So, MVA base, that means from generator side we have taken, generator rating is given 100 MVA 33 kV base 33 kV. So, this 33 kV base voltage and 100 MVA, this thing we are choosing as a base such that Xg will never change, right. Therefore, Xg will remain as it is 0.15 per unit, right. Therefore, KVB line that is your line base voltage will be 33 into 110 by 32, because this transformer actually 32 by 110, line side is 110 kV, right, but we have to convert it to the common base. So, that is why it is, but base voltage we have taken 33. So, line side will be 33 into 110 by 32, that will become 113.43 kV, right. So, now ZB is equal to your kV square base upon MVA base, that is actually 33 square upon 100, that is 10.89 ohm. This is that common base ZB, because base MVA is 100 and this thing. So, ZB T1 is equal to ZB2 BT2 is equal to 32 square upon 110 ohm is equal to 9.309 ohm, right, because transformer T1 and transformer T2 they have the same voltage rating, right, and that is why on the we are your base voltage we are taking 33 kV. So, low voltage side is 32 kV for those transformer. So, kV square MVA is 110 for the transformer, it is given. So, that will become 9.309 ohm, right. Therefore, XT1 and XT2 will be, it is given 0.08 per unit, that means XT1 ohm, XT1 ohm is equal to XT2 ohm, and both the transformer same per unit. You convert it to ohmic values, 0.08 into 9.309 ohm, that is 0.744 ohm. So, this is the ohmic value for the transformer reactance. That means, on its own rating you find out what its base impedance and then you convert it to the ohmic values, right. But base impedance is 10.89, therefore, XT1 new is equal to XT2 new 0.744 upon 10.89, 0.0683 per unit. This is the new values. Of course, this same thing you can use equation 16, that in terms of new and old values of the base quantities and the per unit quantities will come again. So, thank you.